We are talking about GEMDAS, and we are going to use this to evaluate numeric and algebraic expression using order of operations. So basically, GEMDAS, and we may have heard this before as PEMDAS, which everything else is the same. The only thing is we changed the G. Instead of being parentheses, we're going to change this to groups. And we'll see why in a minute. The E still stands for exponents. The M stands for multiplication. The D stands for division. A stands for addition. And S stands for subtraction. Now, the reason that we use order of operations, we use order of operations and GEMDAS as a tool to help us remember the steps in order to evaluate an expression. So when we evaluate, we start with groups. We start over here, and we work our way all the way down to subtraction or addition and subtraction, and that is where we stop. And we can group these together. So addition and subtraction should be grouped together, and multiplication and division should be grouped together. So addition and subtraction are grouped together, and multiplication and division are grouped together as far as when we should decide what steps to do. So this is the process in order to do order of operations. So we're going to use GEMDAS as a rule to help us remember the correct order of operations when we evaluate. And when you think about evaluating, you should think, or in evaluating expression, you should think about building a sandwich. And if you think about it, if I'm making a peanut butter and jelly sandwich, what is the first thing that you have to do when you have a peanut butter and jelly sandwich? Can you spread the peanut butter on the bread without first opening the peanut butter jar? If you don't have the bread already out and you have the peanut butter on your knife, what do you do? Do you spread the peanut butter on the counter? So there's definitely steps that you follow every time you build a sandwich. It's the same thing when you're evaluating a expression or evaluating an equation. We will come back and revisit this for the bottom half of this. So we talked about how this used to be PEMDAS, and the P standard for parentheses. And parentheses is still included in groups. So we can still have something where it says 7 plus x plus 2. The first thing we have to do is what's in the parentheses first. We cannot add the 7 and the 2 right here. We have to make sure that we do what's inside the parentheses here first. This might be a bad example. Maybe I should have said 7 times x plus 2. We can't multiply the 7 times the 2 and then add x to it afterwards. We have to add these in order to multiply. Another example of grouping would be division. And we can group y minus 4 over 5. Okay. we cannot divide this top equation by 5 until we subtract. So even though as we're going down the list, division comes before subtraction, because the y minus 4 is in a group created by the division sign, we have to do what's in the group first. Another way is we can use brackets. And we could say x minus 4, and we could put that in brackets. Or another way we could do is radical. We could say the square root of 9 minus x. So these are all different ways to group expressions together or group terms together. And if we just said parentheses, that would exclude all these other things from that. So we want to change that first one to groups. Different exponents that we could have. We could have a to the 7th. We could have x cubed. That stands for cubed. We could have x squared. We could have 7 to the a, raised to the a power. We could also do square root. Which would be, an example would be like the square root of 40, the square root of 49. We could do cube root. Which would be basically, looks the same, still has the radical, but instead of not having anything written there, we have the cube there. Or we could have a fraction in the exponent, which would be like 16 to the 3/2. So those are all ways to make exponents. Multiplication, different ways that we've seen multiplication. We could see 2 times x minus 4. In this case, if we were going to do multiplication, we'd have to distribute. A lot of times we see 4 times 2. We want to kind of get rid of using that x in there. A better way to write this would be if we wrote it as 4 times 2 in parentheses like that. Or if we had a constant or coefficient written next to a variable, that also means multiplication. So division, we've seen it like 3 divided by 5, y over 2, or 4 over 2. Those are all examples. Addition, we've seen, x plus 4, and subtraction, x minus 4. So those are different operations that we'd use when going through the process of GEMDAS.